my channel. I am Prasad. Now we discuss about the kinematics. Let's go to introduction of the kinematics. Daily we observe so many motions of the object. Some motions are regular, some motions are not regular. For example, we take the earth, motion of the earth. Earth is revolved around the sun in regular manner. Earth is revolved around the sun in fixed orbit. We can expect the position of the earth at particular time of the day. We can also guess in the morning where is the sun and also in the evening where is the sun because follow the regular motion. We don't know mass of the bodies, and also one of the reason for the motion is force. We know that due to force all bodies has motion, but we don't know here how much force acting on the bodies and mass of the bodies and also energy of the bodies. We don't know these, but we can expect the position. How to calculate the position of these objects? Definitely we follow one of the subject, that is the kinematics. So definition of the kinematics is branch of science which deals the motion of the bodies without going to cause of the motion. Without going to cause of the motion mean here cause is force. Motion of the body due to force of acting on the bodies, but we don't to discuss about the force, but we can deal with help of the kinematics. We have a formulas in the kinematics which give the relation among position, distance, displacement, acceleration, velocity, and time. In the intermediate, kinematics has two chapters. One is motion of a body in a straight line. Second one is motion of body in a plane. So these are the two chapters belongs to the kinematics. First we discuss about the motion of the body in a straight line. So motion of the body in a straight line means body is moving in a straight line. So we observe the body motion along a straight line. Suppose observer is at this the point. So this is we taken as a reference point. Suppose body is at this the point. So this point is position of the body. Position of the body is not changed with respect to observer, then body is said to be in rest position. For example, observer is here, so that is the reference point, and somewhere body is here. With respect to observer, the position is always same. Suppose these two bodies moving in a train toward the right hand side, so both bodies are simultaneously moving towards the motion of the train. So here to the observer body position is not changed. Even both bodies are in motion, but position of the body is not changed with respect to observer. So here body is said to be in rest position. So body, observer are moving in same direction with same speed. In such a case, with respect to each other, both are in rest position. Now position of the body is changed with respect to observer, then body is said to be motion. For example, observer is here and body is here. Now after some time, body position is changed with respect to observer. So some distance is changed here. So position is changed. So here body is said to be in motion. It is very need to discuss about the vector and scalar. We know that vector, it has vector mean a physical quantity has both magnitude and direction. Scalar, it has only magnitude but not direction. For example, we take the 2 points, one is A, other one is B. I want to move from A to B. I take 2 paths here. One is straight line, other one is some curve. See here, there are 2 paths to reach from A to B. One along C, other one is moving in a straight line. Along C, ACB path, say it is a curve. Direction is not unique. Direction is not a constant. But from A to B, see here, every point has same direction. So along this line, it has same direction and also magnitude. Magnitude is nothing but here length of AB. Length of AB. So it is vector. So this path is said to be vector. But ACB, so here direction is not a constant. Direction is not a constant. So here it has no direction, but it has magnitude. So it is said to be scalar. For the straight line has a direction, but along the ACB it has not direction. So one length which has a direction, that is called displacement. So displacement is a vector quantity. Other one, ACB has not a direction, so that length is said to be here distance. So distance is a scalar quantity. So what is mean distance? It measures only length. It takes only magnitude, but displacement, it takes magnitude and also direction. See here, body is moving in a straight line from A to B. It has magnitude and also direction. So it has a magnitude, so AB become a distance. And also it has direction, so distance including direction, it become displacement. So here AB is distance and also displacement. Remember that point. When the body is moving in a straight line in the same direction, then distance become equal to displacement. Now the question is, what is the distance and displacement of this motion? Motion of the body is moving along A to B for 4 meters and turns 90 degrees as shown in the figure and move 3 meters and reach the C. For this motion, what is the distance, what is the displacement of the total motion? Distance means total length of the body, in which way body is moving. So first, body is moving for 4 meters in a straight line and 3 meters in a straight line. So distance is here 3 plus 4, 4 plus 3, that is 7 meters. Now what is the displacement? Displacement is a vector quantity, so it has a direction. So I draw straight line from A to C. Here A is initial point and C is final point. So I draw straight line between initial point and final point, that is the displacement. Look here, this triangle is right angle triangle, 90 degrees opposite side, that is the hypotenuse. We know that in right angle triangle, hypotenuse square is equal to side square plus side square. One of the side is here 4, another side is 3. So 4 square is 16, plus 3 square is 9, so that is 25. Hypotenuse square is equal to 25, but I want only hypotenuse, then bring square to this side, then it become root 25, that is 5. So here displacement is a 5 meters. Now the question is, what is the distance and what is the displacement of the motion? So here now body is moving along the circular path whose radius is 7 meters and covers semicircle. Semicircle is nothing but half of the circle. So now the question is, what is the distance, what is the displacement? Distance is length of the path where the body is moving. So this is the length of, so that length is equivalent to the distance. We know formula for the perimeter of the circle, whose radius is r, that is 2 pi r, but we have half circle, so we take only half of the circle, that means 2 pi r by 2. So distance here half of perimeter of the circle, perimeter of circle, so half into 2 pi r, so 2 to cancel, pi r. So what is the pi? Now that is 22 by 7, r is 7 meters, so 7 cancel, so distance is 22 meters. Now what is the displacement? So body is moving from A and reach the point B. So A is initial point and B is final point. So draw a line between these two. So this is the displacement. So every point has same direction. So from this A to B, A to center of this one is 7 meters. From the center again B is 7 meters away. So displacement is here 2 into 7. If radius is r, that is a 2r. Here radius is 7, so 2 into 7 is 14 meters. Suppose body start at a point A and move along the circle whose radius is 7 meters and reach finally to the same point A. To the same point A. Now question is, what is the distance? What is the displacement? So here distance is length of the body where the body is moving. So this is the distance. So distance here, perimeter of the circle, so that is 2 pi r. So path is 2 pi r and radius is 7. So 2 into pi is 22 by 7, r is 7, 7 cancel, we get the 44 meters. Now body is moving from point A and ended at the point A. So here initial point is equivalent to final point. So there is no difference between initial point and final point. So here displacement is 0. Remember, when initial point and final points are coincidence, then displacement become 0. Now question is, what is distance and displacement of the body which is moving from A to B as shown in the figure? See here, we see the center and the angle of ACB is 90 degrees. For this question, what is the distance? What is the displacement? We know that total angle at the center of the circle is 360 degrees. So body covers an angle is equivalent to this is, okay. So 360 minus 90 degrees, it covers 360 minus 90, that means 270. So it covers 270 degrees. If suppose body covers 360 degrees, then we get the quiet circle. For quiet circle, perimeter is formula 2 pi r, but here 270 degrees covers. So how much perimeter it get? So simple logic, it covers 360 degrees. 2 pi r mean for 1 degree it covers 2 pi r by 360. Bring 360 toward this side, then it become denominator. I want to 270 degrees, so both side multiply with 270, then we get, see here, 2 pi r 360 into 270, then we get 3 by 4. So we get here 3 by 4th of 2 pi r, half mean into. So distance is equivalent to 3 by 4th of 2 pi r, perimeter of the circle, half mean into. So that is 3 by 4 into 2, I mean 22 by 7, or is given, that is 7, 7, 7 cancel, 2 2s are 2 11s are, so 11 3s are 33 meters. So it covers 33 meters. So distance here 33 meters. So what is the displacement? See, draw a straight line between A and B. So here A is initial point and B is final point. So from initial point to the final point, draw a line. So we get this is, so observe, this is right angle triangle. So whose of the sides are 7 and 7. I want to this one. So AB is here hypotenuse. So displacement is hypotenuse of right angle triangle. We know in right angle triangle hypotenuse square is equal to side square plus side square. So what is the side? 7 square plus 7 square. So that is 49 plus 49, that is 98. So hypotenuse is equal to root 98. Root 98. See here, 49 plus 49, that means 2 into 49. So 98 is nothing but 2 into 49. So root 2 root 49. Root 49 is 7. So answer is 7 root 2. So here displacement is 7 root 2 meters. Now the question is, what is the distance of the body? Which one is moving? Which is moving along the circle from A to B, as shown in the figure. Where C is the center. ACB makes an angle 60 degrees. See here, ACB makes an angle 60 degrees. What is the distance? So body is moving along the circle. Body is moving along the circle, but here makes an angle 60 degrees. If suppose it covers quite circle, at the center we get the 360 degrees. For 360 degrees, length of the circle is 2 pi r, but here makes an angle only 60 degrees. So for 60 degrees, how much it covers the length? For this question, first you take, for 360 degrees it takes 2 pi r for 1 degree. So it become 2 pi r by 360. So both sides multiplied with 60 degrees, 60 degrees. So we require 60 degrees. Okay. Okay, remember, see here, we get 2 pi r, bring 360 toward this side, then it become denominator and multiply with the 60 degrees. So 66 2 3. So distance here pi r by 3. So that is 22 by 7. What is r? 7 by 3. So 3 is in denominator. So here also, so take 3 in denominator. Now 7 7 cancel. So we get here 22 by 3. That is the distance. Now what is displacement? So this is 7 and this is 7, makes an angle 60 degrees. Now body is moving from A to B along the circle. So initial point is A, final point is B. Draw straight line between A and B. So this length of this straight line is a displacement. See here, these sides, observe this triangle. AC is equivalent to BC. That means definitely this angle is equivalent to this angle. So angle of A is equivalent to angle of B. Say something X. So this is X and this is X. So we know sum of angles in a triangle is 190 degrees. So angles are here X, X, other one is 60 degrees. So sum of these three angles is equivalent to 180 degrees. So x plus x, 2x plus 60, that is equal to 180 degrees. 2x is equal to 180 minus 60, so that is 120. So 260 is on. So x become 60 degrees. So x is here 60 degrees. So we get all angles are equal. Definitely all sides also become equal. So AC become 7 meters. You know that? So this is equilateral triangle. All sides are equal. So here displacement is 7 meters. Now the question is, what is the distance and displacement of the body where body is moving from A along the square and reach the point B? Side of the square is 14 meters. Now question is, so what is the distance, what is the displacement? So distance is nothing but length of the body where the body is moving. See here, first covers 14. So this is the square, so it covers again 14, and this is also cover 14. So answer is 14 plus 14 plus 14. So total length is 42. So this is the square. So all sides are equal. Now what is the displacement? Simple, draw a line, straight line between A to B. So this become displacement. So this is the square. So AB, all sides are equal. So AB length is also become equal to 14. So here displacement is 14 meters. Now the question is, body is moving from point A in a straight line and reach the point B, which is at a distance 100 meters from the point A, and return back to the C, which is at a distance 70 meters from A. Now the question is, what is the distance and what is the displacement for this motion? Now distance is the length of the body, how the body covers, but body covers from A to B. So distance between from A to B is 100. Next, and covers the distance BC from B to C. So from A to B it is 100. From A to C it is 70 meters. So cut at this the point, then we get this distance. Cut means subtraction. So we get 100 minus 70, that is 30. So BC length is 30. So what is the 100? AB length. What is the 30 meters? That is BC. So total distance is 130 meters. Now what is the displacement? Now displacement is, say initial point is A, final point is C. So distance between these two. So what is the answer? That is the 70 meters. So here body is returned back at the point B. So when the body takes return, definitely distance is not equivalent to the displacement. Remember that one. So here body is moving in a straight line and scale is given. Main points are given here. X is equal to 0, x is equal to 5, x is equal to 10. Some points are given here. Those are x is equal to 0, x is equal to 5, x is equal to 10, x is equal to minus 5. Now initially body is at x is equal to 5 and this is the moving and reach the point x is equal to 10 meters. Again it comes back to the x is equal to minus 10 meters. Now question is, what is the distance and what is the displacement? So initial point is x is equal to 5 and final point is x is equal to minus 10. First we measure the distance. So distance is nothing but the length of the path, how along the body is moving. Initially body is moving from x is equal to 5 to x is equal to 10. So here distance is 10 minus 5, that is 5 meters. Again return back from x is equal to 10 to x is equal to minus 10. So what is the distance between x is equal to 10 to x is equal to minus 10? See here. So here this is the positive, this is the negative. So change is final minus initial. So final is 10, initial is minus 10. So minus or minus plus, that is 20. So he returned back 20 meters. So total distance is, see here, he moved along this length, so that is 5 meters, and back again covers 20 meters. So total is 25 meters. So now the distance is 25 meters. Now what is the displacement? Say initial point is x is equal to 5, final point is x is equal to minus 10. Displacement is a shortest distance between initial point and final point, that is from initial point to final point. So this is, so displacement is here final point minus initial point. So that is, what is the final point here? Minus 10. What is the initial point? That is the 5. So here displacement is minus 15 meters. So body comes back. So minus means comes back toward the observer by a distance 15 meters. See here, distance here we get the positive, but displacement is here, that is negative. So body is moving toward the left, so it get negative. So minus indicate here direction, that is toward the left side. So left side is direction.